Good day, folks. Welcome to Guys Mind Academy, where we bring freelance to every lesson. In today's video, I want us to look at now another question under vertical projectile motion. Okay, so yes, so we have a ball of mass 0.06 kg is thrown vertically upwards from a balcony of building 3 meters above the ground. Here is that initial starting point, right? So everything occurs starting from here, 3 meters above the ground. So what happens? The ball is projected vertically upwards, okay, thrown and projected almost the same thing, is thrown vertically upwards like that, okay. Therefore, the ball reaches the maximum height. The ball reaches the maximum height h above the ground, okay. It will reach maximum height, then go back again. As shown in the diagram, ignore the effect of air resistance. Name the force acting on the ball while it is in free fall. We know an object that is in free fall, the only force acting on it is gravitational force. Gravitational force or force of gravity. The velocity time graph below represents the motion of the the velocity time graph below represents the motion of the ball from the instant it is thrown upwards until it hits the ground. So here it is initially V initial when it was projected upwards, right? Then here it is at maximum height, and I know at maximum height the velocity is zero, and here the velocity is zero. I can see that. Then it continues to move downwards. Can you see the distance is not the same because it did not reach the same position. It started here, it went upwards, and then came back. So the distance between this one and this one is just equal, meaning for this one, but going down here it should be elongated like that. Okay, this is where they hit the ground. This is where it hits the ground. Okay, yes. Now they say to us, write down the acceleration of the ball at time t is equal to 1.02. At time t is equal to 1.02, it is at maximum height, right? At the maximum height, the velocity is zero, but acceleration is always down. Acceleration does not change. Whether you are at maximum height, where, always, acceleration, it is always 9.8 meters per second squared downward. It is always like this, downwards or just down, it's fine. This is all they wanted, the acceleration. So acceleration, it is a vector quantity, both magnitude and direction. Okay. They tell us consider the area and they consider the area A1, A2 shown in the graph above. Write down the numerical value represented by the difference in area 1 and area 2. Write down the numerical value represented by the area. So now I want you to tell something. The area under the graph of this one. Actually, now I want you I want you to see something. The slope of the graph, the gradient, it is equal to acceleration. The gradient of velocity time graph, it is what? The acceleration y. Check. Gradient is equal to change in v divided by change in time, which is what? Acceleration, which is what? G. Okay, but now the area tells you the distance, okay, the displacement. You'll see when you have done integration. But now remember, I said here, this is the distance traveled from what? From the balcony to the maximum height. The distance from the balcony to the maximum height. And here will be the distance from the maximum height to the balcony, returning back to the balcony. Okay, but now since it will pass back, it will be now from the balcony moving downwards like this. Meaning, let me say this is 1, this is 2, this is 3. The first part, it is us moving from here to the maximum height, which is 1. Then the second one is moving from the maximum height, returning back to this position, it is 2. Then 3, it is moving from that position to that one. So can you see 3? Consider the area. The difference, it is now A2 minus A3. But can you see now A2 and actually, let me say 1 and 2 are cancelling each other because it is the distance here minus the distance here. What will be left, it is what? Can you see when I cancel that out? What will be left is this. Okay, so what is that? That it is height minus 3 meters. Can you see? It is height. Actually, let me see that. Oh, no, 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 no. So the difference here, it is height 3. Can you see? Here, this one. The height here, it is 3. I want you to be in a position of understanding that, of saying, okay, this is what they're referring to, the difference. The difference will be what? 3 meters. Okay, this will be the 3 meters. Okay. Okay, I hope you understand from this point here to maximum height at 1,02. It is from here to maximum height. Then from there to there, that I show with dotted lines, it is returning back to the maximum, to the same position, and the distance should be the same here. If the distance is the same and they are in opposite direction, they cancel each other. Remember, change y, cancel each other. Then the rest will be what? The height thereof. Okay, they now say, write down the numerical value represented by the difference. The difference will be 3 meters. Okay, the difference will be 3 meters. I hope you understand that. They say to us, calculate the speed. Speed does not have a direction. The speed at which the ball is thrown upwards. Okay, so we know, let me do this. We know here the velocity will be how much? 0 meters per second. And we know the time in which it took to reach the maximum height. Can you see now? 1.02. Then we need what? The initial velocity. It means now I can use this formula that says to us now 12.4.1 Vf, it is equal to Vi plus A change in time, and choose what? Upwards as positive. What is Vf? Vf is 0 at the maximum height. Initial velocity is what I'm looking for. Plus acceleration will be negative. Why? Because I choose upwards as positive. What is my time? My time to reach the maximum height I was given as 1.2. Is it 1.2? 1.02. 1.02. Then I need to be in a position of saying, therefore, Vi, it is how much? Therefore, it is going to be my initial velocity. I need it to be positive. Why? Because I chose upwards as positive, and it is projected upwards. So it is going to be negative 9.8 actually multiplied by just 1.02. I get a value of 9.996. Okay, 9.996 meters per second. Allow me to say, therefore, speed, it is equal to, can I round off this to 10 meters per second? Okay, yes. You can leave it as like this or like that. Remember, the instruction says to a minimum of 2 decimals. So you can, if you convert to 2 decimals, it will give you 10. But if you leave it as like this, it's going to give you, it's still the same. The answer will be the same, okay? But now let us use the same thing. I'll say this is 10 meters per second. But remember, they wanted the speed. I need to say, therefore, speed is equal to. We lose marks by not concluding, okay? Therefore, speed is equal to, okay? Therefore, calculate height h. Height h, it is what? How can I calculate height h? Can you see height h? It is the height from here, from the above the balcony to the maximum height. Okay, this is height, maximum height. Okay, from 0 to maximum height, plus hey, h is gonna be the height to the maximum height. Actually, it is gonna be the height of the maximum, the height that the ball reached the maximum height with, plus 3, because it is from here to there plus the 3. Okay, yes. I hope you are understanding that. So we need to calculate what the height it reached the maximum height. Okay, the distance the ball traveled to reach the maximum height, which is number one, 12.4.2. 12.4.2. So I'm going to say VF, which one should I use? Uh, VF squared is equal to VI squared. Either way that you use 2A change in Y. You can use that of the change in y is equal to time and what, because you have time again. Yes, it's going to give you decimals. Vf squared, I know the maximum height it is 0. Vi initial, it is 10 squared plus 2. What is my acceleration? Negative 9.8. Therefore, my change in y it is what? I don't know. I'm trying to calculate that. Okay. Then when I move this one, when I move this one, it's going to be negative. When you move that in that on that side, it should be negative into 10 squared. Do not put the negative inside, okay? Yes. Yes. Okay. Yes. Then now, uh, I'm in a position of substituting thereof. Therefore, I punch that on my calculator. You're gonna get change in y. It is negative, then bracket 10, you close bracket squared. The negative is outside, then you're gonna divide by 2 into negative 9,8, like that. Then you get a change in y of something like, change in y is something like 5.10 meters. But remember, you want to height h. Height h is gonna be what? 5.1 meters. 5.1. Remember, height, it is just distance. It does not need the, we always plus it, okay? Plus what? The distance, that one, it is how much? It is 3. Therefore, the answer, it is 8,10 or just 8,1 meters. Okay? Yes. This is your answer. First mark, substitution here, adding, final mark. If you do not add, you lose 2 marks. You lose 2 marks because you won't even reach that step. Okay? Now, they say now, after hitting the ground, the ball, let me try to zoom out that for us. After hitting the ground, the ball bounces vertically upwards and reaches a new maximum height, yes, in 1.1 second, okay? So it will reach the ground, okay, and it will move upwards and reach a new maximum height at time uh, with the and reaches the maximum height in 1.1 seconds. So it will reach the maximum height in 1.1 seconds. So they say calculate the work done by the ground. Calculate the work done by the ground on the ball while the ball is in contact with the ground. So we want to calculate the work done by the ground. Okay, the ground will do a positive work on the. Remember, when it reaches here, the ground will push the ball back upwards. Okay, Newton's third law. The force that the ball reaches down with, as well as the. Okay, remember, it will reach with the gravitational force downwards, but the force upwards force that the that the earth exerts on the ball, which is the normal force, will be opposite. So we want to calculate the what? The work done by it. Okay. So how can I do that? First thing first, I need to know the velocity here. The velocity that it went upwards with. Okay. The velocity that it went upwards with. What I know is that velocity I don't know. I know the time. I know the velocity. It is 0, and I know the acceleration. So the formula that I can use it is what? VF and what is equal to change in time, what. Okay, this is number 12.5. This was a very, very interesting question. 12.5. I'm going to say VF, it is equal to VI plus A change in time. Upwards is positive. Therefore, V final, it is 0. Therefore, I want V initial, the one that it moved from the ground to reach the maximum height with again. Okay. Acceleration, it is 9,8. Therefore, the time they're telling us it is 1.1. Therefore, the initial velocity is something like 9.8 multiplied by 1.1. Therefore, it moved upwards with a velocity of 10.78 meters per second. And it should be greater than the velocity it reached the ground with. Okay. It reached the ground with a velocity of how much? We don't know. Okay, we don't know. It's fine. Okay. Then now that we have calculated the velocity here, what do you want? What do you want? Calculate the work done by the ground, okay? By the ground on the ball while the ball is in contact with the ground. So another thing that I will need is, okay, the force, the force, okay? The force. Calculate the work done by the ground on the ball while the ball is in contact with the ground. So here, remember, the forces are not equal. The forces are not equal. It is going to be the force of gravity acting downwards. Then, actually, let me say, if I have an object like this, there will be a force of gravity. But now we will have a very upward force that you do not know that will cause the object to move upwards, right? So they want the work done by the ground, okay, on the ball. So this, let's just call it force of the ground. Okay. Now We want to know how much is this force. How can we do that? I can do that by saying, okay, how about I calculate the I use work energy theorem. I get work energy theorem because this is the okay. Oh, I will also need the velocity it reached the ground with. Okay, the velocity in which it reached the ground. Okay, the velocity it reached the ground. Then this will be the velocity nu when it went up. Okay, why? Because I want to use this. W net is equal to changing k, because I'll say it is the force of the ground gravity plus the force of the ground. It is equal to changing k. This was a very interesting question. So now let us also be in a position of calculating the final velocity it reached the ground with. Okay, so it's gonna be what you're gonna say. This is the velocity it moved it moved upwards with from the ground but let us calculate the velocity when it reached the what reached the ground. I'm gonna say I can use uh, this one. I need to use this one. Oh, I need to use this one. Vf squared is equal to vi squared plus 2a changing y. I still choose upwards as positive. The final velocity is what I'm looking for. The initial velocity we calculated, it is 10. It was 10 again. The initial velocity of the block, okay? It was 10 squared plus 2. What is the acceleration? Negative 9,8. Now I want to cut. What exactly am I wanting? Changing y. I want you to see this. Changing y here is gonna be it moved upwards like that. Okay, let's say distance d and went back the same distance but in opposite direction. It will be negative d, then plus negative 3. Okay, so this is the changing y. Changing y will be now the displacement from here to reach the ground. It will be whatever this distance is here. Okay, so this will cancel out. It will be just negative 3. Okay, yes, negative 3. Then let's check. I get a final velocity of how much? 10 squared plus 2 into negative 9,8 multiplied by negative 3. I get a number of 12.60 meters per second. Remember, this is down. This is moving downwards. Okay, this was moving upwards. Why am I saying downwards? Because now final velocity, when you use this formula, it can never be a negative, but you should remember it was moving downwards. So remember I said the final velocity, the velocity in which it went upwards with will be less than the final velocity at the ground. Why? Because now energy is lost. But now the question is, what do we want? We want the work done by the ground. So we're gonna say, okay, W net, it is equal to change in K. What is W net? Work done by FG plus work done by the ground is equal to a half m VF squared minus VI squared. What is the work done by the FG? Work done by FG, it is mass multiplied by gravitational force, right? And now we need to know the direction. Shit, changing D. I also note, okay, the distance here, this one traveled, it is how much? Can I just see something? The change in D, it is the what? The distance, uh, change in D, it is the distance that the weight traveled from here to here. Okay, so FG moved from there to that one. So the distance it traveled, it is how much? I think we calculated it. Height H. Here it is, height H. Okay, that height, all of it, it is how much? 8.10. So it's going to be mg mg multiplied by change in x cosine of an angle plus work done by the ground. This is what I'm looking for. It is equal to half mvf squared minus vi squared. Then now what is my mass? Did they give me the mass of the object? They should, because if they did not, it is problem 0.06. 0.06 multiply. What is my change in x? My change in x, it is 8.10. Yes, my change in x, it is 8.10. The total distance 8.10. Cosine gravitational force, it is doing what? Negative work. It is actually, I want you to see something. Gravitational force, it is doing a the motion, the direction of motion, it is going downwards. Okay, and also fg, it is acting downward, so it means fg, it is doing positive work. Okay, because now the ground, it is opposing, so it means now force of the ground, it is doing negative work. It is trying to cause a change thereof. Therefore it means this one will take negative 180 degrees, this one will take 0 degrees. Okay, so the ground, you need to consider the direction. Do not say always gravity is negative. You need to see where the ball was displaced initially. This is 0 degrees plus work done by the ground. It is equal to half. What is my mass? 0.06. What is the final velocity? Final velocity we calculated as 12.60 squared minus initial. It is initial was 10 squared, if I remember very well. Okay, therefore you do a mathematical gymnastics. Work done by the ground, it is equal to 0.5 multiplied by 0.06 multiplied by 12.60. Okay, 12.60 squared minus 10 squared, then subtract by 0.06 multiplied by 8.10 multiplied by cosine of 0, which is 1. Then I get an answer of 1,2768. So to two decimal, it is 1,28 what? 28 what? Joules. And it's weird how I'm getting a positive number here. It's weird how I'm getting a positive number here. Let me see if I'm doing anything wrong. Oh, we chose upwards to be positive. Okay, remember, therefore, it is displaced in the negative direction. Okay, it is displaced in the negative direction. Therefore, I need to change my changing my what negative 8.10, my 8.10 to negative, like that. I still get a negative answer, a positive answer, I mean. Okay, I still get a positive answer, but now of 2.25 joules. I want to see if I did something wrong or I misinterpreted something, maybe. Okay. Here I did not substitute the G. I did not substitute the G. I just said it is 0.06. Then I need the gravitational acceleration. It is negative. Okay, it is negative. Or let's just choose downwards as positive for this one. Why? Because now it is the distance, the change in x, it is acting downwards. Okay, the change in x, it is acting downwards, so it's fine. We'll just say gravitational, it is 9.8, like that. Then the distance, it is how much? How much was the distance there? The distance was 8.10. Okay, yes, let me repunch that one on my calculator and say, okay, 8.10 multiply by 9.8 again, and exactly. Yes, I become happy. I get an answer, sorry, of -3 joules. Okay, so that's all. Let me try to get a memo for this one and confirm the answers. Okay, I can't remember which one this one I took from which question paper actually, but let me try to find a memo for this one and then try to show you if we done things correctly or not. All right, I am back now. I found the memorandum. So the memorandum now confirms that these first three answers 9,8, 3 meters, 10 meters per second. First one, 9,8. Here it is. Where is it? Here it is. 3 meters, correct. 10 meters, sorry, correct. 8.1, correct. But now it says now this one, it is not -3. It is rather -1.2. Why? Because now instead in my change in x, I substituted 8.10, okay, which is the height. Whereas the change in x, it is the displacement, meaning I was supposed to say this is now the displacement between from here to there, which now makes my displacement now -3, because from here to there it cancels off. Then the last remainder, it is that one. Okay, so now I should be in a position of saying, okay, instead of using 8.1, we should be using what? 3. That's our displacement. Let me try to confirm if that's the case, or I'm adding things up. But yes, these are the few things that we need to take note of. Okay, yes. Minus 0.06 multiplied by 9,8 multiplied by 3. Indeed. Now it tells us now this is the answer. Okay, I don't know what's happening here. 9,8 multiplied by 2. A little bit, just a moment. Want to see maybe something that I'm doing wrong here in my calculator. Okay. mg change in x cosine of theta, work done by the ground, half m, this one minus that one. Okay. Um, want to see something again? Let me. Okay, so I went on to look at the memo then. The memo now disagrees with my answer. Okay, so I wanted us to be in a position of seeing how exactly they did it. So we did calculate initial velocity, right? Here's the initial velocity, 10.78, right? Okay, there it is. So it means we have our first mark here, second mark there. Then now they did what? I also did wrong substitution there. Then they also got 12.6, the one that I got here. Then when they came here, they said now, okay, W net is equal to change in K, which is 0.31. Here it is even 10.7, 10.78, like that. Then only. So basically, they do not have where now they substitute work done by the gravity. Oh, okay. It's because now at instant it reaches the ground. Remember, it is in free fall before it reaches the ground. The minute it reaches the ground, there is no longer there is, but it is no longer FG now. But okay, then what they do? They just substituted that into the equation thereof. Then they got something like well, um, okay. Now it means we'll get a okay. We lose a mark formula here. Then whatever that they did here. So that's the one that they did. So the answer is basically this one, okay, -1.28 from this one also told us is -1.28. So now it means we had to remove this part from our calculation. So it is 0.5 multiplied by 0.06, then 10.78 squared minus 12.6 squared. And that's how they get their negative 1.2. These, you really find these questions in exams where they mix, but you should be aware. They like to do that, especially in when you are writing a supplementary exam. If you are writing a supplementary exam, then you should be very, very aware of that. They like to put it in those question paper. So thank you very much for joining me. I hope you enjoyed, and let's meet on the next video.